Hi and welcome to a Kirby Maths video about comparing box plots. So we have here two box plots, and these box plots have been drawn as a result of some data we had about the amount of time it took some girls to solve a problem and boys to solve a problem. And we drew the box plot after we had sorted out the data, and we have a minimum value here, which is the end of the whisker. We have the maximum value here, which is the end of the whisker. The ends of the box are constrained by the lower quartile and the upper quartile, and the median is the line that is drawn in the position of the median within the box. And it's the same for the boys. They've got their minimum value, their maximum value, lower quartile, median and upper quartile. Now, when you are asked to compare box plots or talk about the distributions of the data and you are given box plots, then there are two things that you must always compare. You can compare other things, and I'll go on to that at the end of the video, but you must compare these two things because generally that's what the marks are for. So the median values, which are these values here, and you read off from the scale below, and the interquartile range, which is the upper quartile take away the lower quartile. So that value take away that value will give you a numerical value, and the value here that you read off the scale take away the value here again will give you a numerical value. So I'm going to talk about the median first of all, and I've written something down here, so I'll just read through it and then talk about it. I have said that the median time for girls was less than the median time for boys. It was 19.9 seconds compared to 21.1 seconds. This means that on average the girls solve the problem more quickly than the boys. So there's a couple of things that's really important to include when you are comparing box plots. You have to say the thing that you're comparing. So first of all, first thing we're comparing is the median. Okay. You then have to actually do the comparing and say whether one was bigger than the other. So here I have said that the girls' median, this value here, read off this scale, was less than the median time for the boys. Once you have said which one is the larger of the two, you then need to talk about the actual values. So here is the 19.9 seconds and here is the 21.1 seconds. You must then interpret in terms of statistics what this actually means. And it means that on average, the girls solve the problem more quickly than the boys. And this is looking at what this data means. This is a faster time than this, if these two numbers are in seconds. If you're given something like weights or heights, then you need to make sure that you've got the context of the numbers correct. Okay, so if this was weights, for example, this is a lighter weight than this. And they really do like to give you questions on time, because often the smaller the value of time, the better it is. So if you're having the times for a 100-meter race, for example, the smaller the time, the quicker the person is going. Okay, so just be careful of the context of your data. Moving on to the interquartile range, we then need to look at what I've written for the interquartile range. So I have said that the interquartile range for girls was greater than the interquartile range for boys. It was 3.7 seconds compared to 2.7 seconds. This means that the boys were more consistent in the time it taken to solve the problem. There was less spread in the central 50% of the data. So again, we are saying what we are comparing, the interquartile range, and we are saying whether it's bigger or smaller. Okay. So the interquartile range for the girls was bigger. It was 3.7 seconds compared to 2.7 seconds. And we list the numerical values showing our comparison. And then we go on to do our interpretation. This means that the boys were more consistent. So a lower interquartile range means greater consistency. Let me just write that at the bottom. So lower interquartile range, more consistent. Okay, so if your interquartile range is small, it means that your data is more tightly grouped. The middle 50% of the data is more tightly grouped about the median, okay, and that's better from a statistical point of view. So it's more consistent in the time taken to solve the problem, and then this is just like a little bit of an add-on. There was less spread in the central 50% of the data, because that's what the interquartile range is, isn't it? This is 25% into the data. This is 75% into the data. That means we are looking here at the middle 50% of the data. Okay, so just to recap, you must always compare the median and the interquartile range. You must state the values. You must state whether one is higher or lower, and then you have to interpret what that means. Does it mean that they were quicker at solving the problem? Does it mean that they were quicker at running the race? Does it mean that they were heavier? Does it mean that they were lighter? And secondly, with the interquartile range, again, you have to say whether it's greater or smaller. Compare the actual interquartile ranges, so how long these boxes are. And finally, saying whether this means that the boys were more consistent or the girls were more consistent. And finally, there are other things you could compare on these two box plots. For example, you could say that the quickest girl here, the one with the minimum time, was quicker than the quickest boy, because her time is around about 16.2 seconds and his time is around about 17.4 seconds. You could say that the slowest girl who took the longest time, 23 seconds, was quicker than the slowest boy. His is around 25 seconds. Or you could compare the actual range, which is the maximum take away the minimum, so 25 take away 17 point something, or 23 take away 16 point something, and talk about the overall range. But mainly what an examiner is looking for are these two quantities discussed and compared and stated. Thanks for watching.